Hello, my name is Jamie Monroe, and I am presenting today my applied project on the effectiveness of differential reinforcement of alternative behavior, DRA, to reduce leash pulling in a pet dog. Behavioral problems are known to increase the likelihood that a pet owner will relinquish or euthanize a pet, which is why it is important to address behavioral problems with pets as we would with humans. There is some research to support how functional analysis and function-based treatment can decrease dog behavior problems. The research shows differential reinforcement of other behavior and non-contingent reinforcement being effective in reducing jumping up behavior when the function is for attention. DRA has also been evidenced to be effective for reducing kennel aggression when escape maintained and leash pulling when sensory maintained. The participant for my project goes by the pseudonym Rose, who is a 3-year-old goldendoodle dog. Rose engages in leash pulling behavior, causing owner frustration and need for intervention. Through functional analysis, it was hypothesized Rose would primarily pull the leash to gain access to items on her walk to smell, thus having primarily a sensory function. Leash pulling was an important behavior to target for intervention because the behavior was interfering with Rose's functioning, as owner frustration led to less frequent and/or shorter walks, resulting in less overall walking time. Therefore, Rose was being restricted from opportunities to exercise, socialize, and engage in mental stimulation, all of which are important for her overall well-being. Increased owner frustration was also creating fewer opportunities for quality time, negatively impacting Rose's bond to her owner. A multiple baseline design across settings was used. Data collection was done using partial interval recording. Each session consisted of a 5-minute walk, which was divided into 10-second intervals for a total of 30 intervals. A session was conducted in all 3 settings, the street, the park, and the hiking trail each day. Therefore, the independent variable was introducing DRA plus extinction to see if it would cause the dependent variable, leash pulling behavior, to decrease. The percentage of intervals with leash pulling was graphed to visually analyze for a functional relation between variables. The procedure included baseline, which did not apply the intervention and therefore did not redirect Rose to stop pulling on the leash. This allowed a measure of Rose's initial percentage of leash pulling during a typical walk before introducing the intervention. Baseline started at the same time in each setting, as seen on the graph, and continued until intervention was introduced. Intervention was applied to each setting at staggered times and included a least to most prompting and fading procedure on a trial-by-trial basis when Rose would pull the leash. As pictured, if Rose pulled on the leash, her owner gave the verbal instruction, sit. If Rose did not sit, the demand was reintroduced with a gesture prompt. If Rose continued not to sit, the demand was reintroduced with a physical prompt, placing their hand on Rose's haunch and gently guiding her to sit. Rose's owner would also apply prompt fading throughout the walk. Therefore, if a physical prompt was required for Rose to sit, her owner would start with a gesture prompt for the next trial. Similarly, if a gesture prompt was required, a verbal prompt was given at the start of the next trial. Meanwhile, if Rose sat independently without prompting or reduced her walking speed upon discriminating pressure from the leash, she received a treat from her owner with enthusiastic praise. During baseline, leash pulling occurred at consistently high levels across settings, with an average of 89% of intervals. Upon intervention, leash pulling gradually decreased and reached near zero levels by the end of the intervention. As you can see on the graph, at session 6, a sweeping gesture was introduced to increase procedure integrity, as Rose, being in front of her owner during walks, was not oriented to see the gesture, thus not responding to the prompt. Leash pulling decreased to an average of 9% of intervals in the last 5 sessions. As you can see from the graph, some variability of leash pulling was observed in the street and park settings during intervention, with more steady low rates on the hiking trail. Overall, DRA plus extinction did improve leash pulling across all 3 settings, as the percentage of intervals with leash pulling significantly decreased once intervention was introduced, thus displaying a functional relation. To conclude, teaching alternative behavior seems effective to reduce leash pulling behavior, but reinforcement is essential to motivate behavior change. During the last 5 sessions, when near zero levels were most prevalent across all settings, treat reinforcement was averaging 8 to 12 treats per walk, where previously it averaged 1 to 4. Rose was observed to be keeping a loose leash and would look back for reinforcement when she slowed down or sat independently after feeling pressure on her leash. Therefore, the results add to current research for applied behavior analysis principles, effectively decreasing undesirable behaviors for dogs, as there is another study demonstrating DRA reducing leash pulling behavior. Some future considerations I would include is a maintenance phase to ensure the intervention effects are prevalent over time, as well as including to fade reinforcement with variable intervals rather than always continuous, as 12 treats per a 5-minute walk, which in the 3 settings is a total of approximately 36 treats per day, is not realistic or sustainable over time, as it does not promote independence and could pose health risks to Rose if overeating daily. I would create a checklist for both behavioral skills training with the owner before intervention and complete a procedure integrity checklist during intervention to ensure the procedure is being executed accurately, to ensure the variability seen in the data was not due to procedural drift. Consideration for extraneous variables with outdoor environments and settings is also important when analyzing the variability of leash pulling across settings. I hypothesized the hiking trail had less variability due to having a concrete path with trees hugging the sides of the trail, tightly closing off any wandering behavior. Therefore, most scents were kept on the trail by previous walkers for Rose to access without pulling. Meanwhile, the street and park entailed less structured paths, encouraging Rose to seek beyond the designated path to gain sensory output. The street and park were also higher traffic areas this time of year. Being winter, the hiking trail had fewer encounters with other dogs. Therefore, additional target behaviors could be considered with an appropriate leash walking behavior, such as how to redirect Rose if she lunges at a person or other dog passing by and begins barking for their attention, as there was evidence of attention-maintained leash pulling during these instances. Therefore, this could have also contributed to the variability in data in the higher traffic settings, and future studies could explore incorporating a DRO or NCR for these instances. My references are also included here if you'd like to explore these studies more. Thank you so much for listening.